Okay, so what we go over today will allow you then to break back into lab groups and do those little bit of calculations that we talked about that we couldn't do as we collected our data. So when we look at these things, we can call them enthalpies, heats, or energies of. Whenever I'm talking about these things, I use the symbol delta H. I'm on freeze? Well, shoot. I've been having a lot of trouble lately. Okay, so this little delta H means change in enthalpy, change in heat, change in energy. I can have a delta H that I can write as delta H FUS, delta H VAP, delta H SUB, delta, I'm trying to think, oh, I hit the major ones there. I could do delta H of crystallization, or sometimes you'll just see SOL for solidification. This delta we know means change in. Change in, let's talk about this as being change in enthalpy. When we talk thermodynamics, that's most often what we would call it. Now, when we worked with the sodium thiosulfate pentahydrate, we didn't really have to worry too much about water. So we have to look at things like delta H can be equal to the mass of the substance times the temperature change of the substance. So this is my mass. This is my change in temp. Unlike the gas laws, when I use this, I can work with degrees Celsius. And my mass is generally in grams. So in your lab, we were talking about the heat absorbed. So we can use delta H equals M delta T to do those calculations. So I'm looking at grams times degrees Celsius. Now the other way that I sometimes have to use this is Q equals MC delta T, or sometimes you'll just see Q equals MC. Well, it's almost always delta T. Sometimes it's T. Where Q is quantity, I'm going to say of heat. We could say quantity of enthalpy. We don't usually, though. This again is my mass in grams. This C stands for something called specific heat, and every substance has one. When I talk about specific heat, I'm talking about the quantity of heat required to raise the temp of 1 gram of a substance 1 degree Celsius. And of course my last thing here is temperature change in degrees Celsius. So what I want you to do, this of course we talked about this before, quantity of heat is going to be measured in joules. What I want you to do right now is I want you to rearrange this equation in terms of C. So take a minute, rearrange your equation in terms of C, and tell me what the units on C are. When you've got it figured out, stand up. When you have your units on C, stand up. I'm going to wait as long as it takes for you all to stand up. I've given you all the units that you need to figure it out. Okay, find your partners. Lab partners, lab teams. Check your units, see if you agree. Okay, once you've talked, come on back. Cole, you were the first one that popped up. What was your answer?
Q over M times delta T.
Q over M, delta T. What are those units?
Calories.
Ah, good. You're a step ahead. If I break these down, what do they look like? What's Q? Marin? What are my units on Q? Drake, what are my units on Q? Joules. Joules per. What are my units on mass, Maria? Grams. And Evan, how about temperature change?
Celsius.
Degrees Celsius, yes. So C is actually, unit-wise, joules per gram degrees Celsius, which I actually call, what, Cole? Calorie. Good job. A calorie. When I define calorie, I would say it is the heat required or the energy required at 1 atmosphere of pressure to raise the temperature of 1 gram, it's a little bit different, of water 1 degree Celsius. So when I talk in calories, I'm talking about comparing it sort of with water. There are some standards that you have to remember as you do this. My delta heat of fusion for water is equal to, which would really be ice, I guess we should put in parentheses, 6.01 kilojoules. That's fairly large. And when I talk about my heat of vaporization of water, that is equal to 40.7 kilojoules. And those are numbers that we'll just have to remember, and as we move through, I'll give you a few more. Lots of times this calorie, you will see it as kilocalories, which would be 10 to the third calories. So it's the same simple conversion that we do with all the other stuff. Sometimes, especially if you're in a place where they use the metric system full time, you'll, instead of seeing calories, you'll see kilocalories on things listed. So at this point, you should have enough information to go back, and let's start with our heat of crystallization lab. and do those calculations that you have your data collected for, and I'll just be moving around the room answering questions as needed.